Good noon to one and all present here. It's my pleasure to introduce the great scientist, Dr. Mathilesh Satyanarayanan, founder, CEO, scientist of MIT Square, London. That's a small intro about Mathilesh. Let me do it. Mathilesh is an educationalist, technophile, innovator, and a social entrepreneur in the field of education, engineering, healthcare, and hospitality sector. He is a motivated, committed, and an adaptable researcher with professional and technical skills developed through past work experiences in the computer science research field. He has a methodological, analytical focused approach to work and a strong drive to see things through to competition. His research focuses on digital humanities, digital experience, communication science, data science, information science, forensic science, business intelligence, human computer interactions, human data interaction, visualization, and social informatics. Dr. Mathilesh received International Achievers Award in recognition of outstanding professional achievement and contribution in nation building. The Indian Achievers Award, India's most weighted award recognizing achievement since 2000, and organized by the Indian Achievers Forum, Government of India recognized organization. While he was 15, a serendipitous event inspired to take research, development, and innovation. This sparked his interest in engineering at the UG level and communication science at the research level. He received a fully funded research fellowship to pursue PhD at the City University of London in collaboration with Redshift London. Later, he went on to complete the industrial postdoctoral fellowship, worked as a young scientist and a guest lecturer at universities in UK. His expertise researched at both theoretical and application levels ranges from industrial projects to academic ones in domains such as education, engineering, healthcare, and agriculture. Worked with several countries and industries, which has led to several innovations, publications, and patents. Now he is the founder and CEO of Mighty Square, a product development company which focuses on the latest technologies to build scalable and reliable products that can make a visible difference to our community. Has published various papers. One of the notable one are artificial intelligence for business management professionals, blockchain technology for business management professionals, and IC3A 2019, and conferences. Most of the conferences and journals in 2019, and also the collaborations with industries in 2019. He has worked with various countries such as Asia, Africa, Australia, Europe, North America, South America, University of London, University of Britain, Japanese University, Rajiv Gandhi Institute of Technology, Sri Siddhartha Institute of Technology, Sri Sairam Engineering College, Weller Institute of Technology, Castania State Institute of Technology and Management, SISTI, Talent Bus, Vidya Global, Professional Researchers and Entrepreneurs, and etc. He has also worked with various professors in various countries. Welcome, sir. There is a warm welcome from our side. Thank you so much.
Thank you, sir. Thank you so much for the lovely introduction. It really means a lot.
Thank you.
So it's amazing. Thank you so much.
Thank you so much. Yes.
So, yeah. So, shall I start the presentation?
Yes, sir. With pleasure, sir. You can start over the session now, sir. Thank you, sir.
Thank you, sir. Thank you.
Thank you.
So, is the screen visible?
Yes, sir. It's visible.
Okay. So, first, I would like to thank Christ College of Engineering and Technology for providing such a wonderful platform for the students and the professors. I feel really proud. These kind of colleges, need to come forward to conduct these kind of webinars and seminars. This will definitely make a massive difference to students and, professors. My special thanks to Dr. Tyagarajan sir for reaching out to me and coordinating so well. I've been closely working with Tyagarajan sir for the last few months. He's really phenomenal. His energy is quite amazing. At this young age, he has a lot of energy. I would strongly encourage you to do further, sir. Thank you so much. I will straight away dive into the topic. Yes, sir. So for today's discussion is on technologies, how we can be innovative, how we can turn an idea into a product deployment, how to push it into the market. So very simple, straightforward. I'm not going to get really in depth because this kind of topic needs at least 4 to 5 hours, but I'll try my best to finish in 1 hour so that you understand the high level idea and you start working on the projects. You can motivate your students. If students are already present, then it could be really good. Students also will understand how to take an idea into the deployment stage. Before we completely delve into the whole stages of the product development, we'll try to understand what is Industrial Revolution all about. Industrial Revolution is nothing but an interaction between people and machines to make life easier, to make work better and faster. We have moved from Industry 1.0 to 4.0, and we'll be moving towards 5.0. Still, there's a lot of research going on. Google, Amazon, and other folks, big giants, are currently working on 5.0. But still, India is between 3.0 and 4.0. So we call it as 3.5 exactly, but it's not a well-defined term. But I would just call it as 3.5. The reason is we have not completely shifted from 3.0 to 4.0. In 4.0, we have all the latest technologies like robotics, cybersecurity, blockchain, IoT, augmented reality, extended reality, additive manufacturing, 3D printing, and so on. A combination of these makes completely Industry 4.0. Let's see how we have evolved from our 1.0 to now we are moving towards 5.0. Let's see what are the things that have changed over a period of time. In 1.0, we call it as more of a production kind of a revolution. That's where we started coming up with mechanics. One of the greatest invention was steam engine. I guess it was invented by... Sorry?
Sir, just a moment, sir. Sir, are you displaying any PPT, sir? Because no PPT is displaying here, sir. Sorry to interrupt.
Sir, no. Sir, display agada.
Display agada?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. It's displaying. PPT is displaying.
Okay, that's all right. Because okay, that's all right. Okay, so in Industry 1.0, in the production revolution, the focus was completely on the mechanics. For example, one of the greatest invention was steam engines that was invented by James Watt, if I'm not wrong. Like one of the strategic differentiator was steam power, mechanization. That point of time, they never came up with something using electricity. So it was completely on the mechanical side. Slowly, we shifted to Industry 2.0, which is nothing but industrialization. The focus was on electricity, electricals, and so on. The strategic differentiator was mass production. They wanted to build a lot of machines using the electrical concepts. From 2.0, we shifted to 3.0. That's where we started seeing more of electronical components, computers, and so on. And automation came into place. For example, robotics, doing a lot of automated work for people. It could be in various sectors. It could be in healthcare. It could be in other engineering sectors. And currently we are in 4.0. As I said, we are trying to shuffle between 3.0 and 4.0. In 4.0, it's more of cyber physical systems. That's a combination of IoT, AI, and blockchain, and something of that sort. Or it could be just a combination of IoT and AI. The strategic differentiator here is mass customization. So they started customizing things for people. Rather making it personalization, it's more of customization. But whereas Industry 5.0 is completely user-centric, or we call it as customer-centric. Based on each customer's requirement, we start developing a product. So that's what going to be Industry 5.0 all about. This can happen between 2025 to 2030, probably. And mostly you will see Western countries coming up with this kind of solutions. India will take some more time to really catch up because still India is not up to Industry 4.0. And in Industry 5.0, we'll see super fast manufacturing systems. That's going to be a revolution. I think Germany has already started working on 5.0, so we'll see a lot of interesting products there. And yeah, that's pretty much. In terms of success of innovation, we see 3 layers, which I personally believe if you want to be successful in innovation, you need to have a very strong grounded research that's from the academic side. For example, if Christ College is working on some kind of academic research, they need to set up that platform, have some kind of an incubation support as one of the second layer. And in terms of a third layer, they need to start collaborating with industries. And it's great that Tyagarajan sir has reached out to us to make sure it completely grounded as one of the products that can be deployed. So it's good. We need more professors to start collaborating with a lot of industrial people and incubation sites. We have Atal incubation as well in India. If you need any kind of support, let me know. I'm happy to connect. This is where the college, the students and the professors will start seeing the project ideas into a product. So that's where I personally believe the success of innovation comes. Okay, let's see what is disruptive technology all about. We start doing some kind of small projects and works, but we need to think a little bit ahead. If you want to reach the 5.0, then we need to understand what is disruptive technology all about. Disruptive technology is an innovation that significantly integrates various technologies. We can't just say I'm using IoT concept and building a solution for a smart city. No, it doesn't work that way. You need to really think how you can connect IoT with cloud and artificial intelligence if you want to make it a very sophisticated smart city solution for betterment of the community. So that's where disruptive technology comes into play. And the moment these kind of integrated technologies comes into play, it alters the way people start thinking it, or industries, and the way business start operating. So the whole thing, we call it as disruptive technology. I'll be showing some kind of a case study that we tried to work a couple of years back, a very successful solution that's being deployed in London. I'll walk you through the case study, but before that, in our disruptive technology, we use something called visual analytics. That's nothing but visualizations plus artificial intelligence with web development. We worked with a domain called digital forensics. I will explain you what is digital forensics all about. So in the case study, we'll be working on email communication analysis to support digital forensics and e-discovery. It's completely in the investigation domain that can be used for organizations to understand where some kind of hacking or some kind of sensitive information being transmitted to different people. So that's completely on the investigation side. This is one of the products that we worked a couple of years back. So what is digital forensics? Digital forensics is an investigation domain that uses the system to recover and analyze a lot of data that's found in various devices, often in relation to digital crimes that's being happening. It could be hacking, it could be spam, it could be various other criminal activities being digitally misused for. The whole domain is called as digital forensics. Under digital forensics, you have something called e-discovery. It's one part of the criminal investigation. What is e-discovery now? E-discovery is nothing but a domain where electronic or digital communication data is being sought, located, secured, and searched with an intent of using it as an evidence in any of the legal cases. For example, it could be social media data. Let's say that a group of people start abusing you, racially abuse you, or it could be bullying you. We call it as cyberbullying. These kind of activities, it could be anonymous. So sometimes we do not know from where exactly the person is acting from. It could be a fake profile. It could be anything of that sort. So e-discovery comes into play to identify those things, capture the data, do some analysis, and understand at what instant of point, which location, exact location the person is from. And for this, we need some kind of a very quick solution so that the investigation time reduces. So for us, the motivation was most of the legal companies started using manual kind of investigation, especially with email communication data. In the email communication, we have people who can send a lot of sensitive information outside the organization. Let's say that in Christ Engineering College, you have some kind of data that has to be only within the professors, whereas the professors start leaking the information to the various other organizations for whatever purpose. So in that case, there'll be this kind of investigation where they would like to understand why certain people have transmitted this kind of information which is sensitive. So this is where the e-discovery comes into play. Whereas in big industries or any other small industries, data has to be protected. You cannot leak the information, so the employees can be severely punished. There are a lot of examples in America. For example, Enron is one of the company where it started sending a lot of sensitive information to different organizations to get a lot of, to improve their stocks and to get a lot of bribe for other purposes. So investigation comes into play to identify why certain individuals have done certain things at what point of time. Is it really they have done it with intention or non-intention? So these are the things that happens in the investigation. To do that, you cannot do just manual investigation. Just go to Gmail, for example, and start searching all the emails. It's not possible. Doing any kind of manual investigation takes enormous time. A lot of cost is involved. And it's more of a complicated process. We need some simple solution. That's where the investigators reached out to us to develop a solution to make life easy for them, to make very non-expensive and make it very time-saving one. So the current problems, we always, whenever you start building a solution, it's always good to understand the problems, current problems, try to do some kind of a sketching. Then you try to build a proposed model. Again, you need to do some kind of drawings, which is always a good practice. Whenever you start a new project, it could be your DST funding, or it could be even a very simple projects, or even if you're doing PhD, for example, it's always good to come up with some kind of a sketch, understand the current problems, and then try to propose a model, and then you draw the diagrams. So in our case, in this particular case study, we try to understand the flow pipeline of the current problems. There we understood where it is really tedious, where it is time consuming, where we feel it's really expensive. In the proposed model, we try to make it as simple as possible, try to build a web-based solution which makes life easy. It's going to be a very simple process, significantly cheaper, and it doesn't consume too many resources as well. So that's our proposed model. And it's always a good practice, irrespective of academic or industry. It's always a good practice to come up with a research question. Even if you're starting your PhD, please do start with a research question, come up with a hypothesis that you want to really test. And my PhD actually gave me a ground getting into the industry to, this kind of finding the methodologies and methods. It really helped me. So I would strongly encourage the professors and students to really focus on identifying the research question first. That will help you establish aim and then objectives. I'll walk you through those. But just to understand this case study, let's see what the research question we came up with. To what extent visual solutions or a visual platform can support analysts in finding relevant and discovering interesting information in a corpus of email within an organization that's related to investigation? So that was a very simple high-level research question that we set it up. Our overall aim was to design and develop interactive solutions to explore and find various interesting information in an email. Again, from investigation perspective, so that we can support organizations in e-discovery and digital forensics. So our aim is very simple. Just develop a solution that can make life easy for the investigators. As simple as that. And when we dive into objectives, again, it's a very good practice to set up 4 to 5 objectives. Whether you're writing a proposal or whether you're doing your PhD, it's always a very good practice to come up with objectives. So in our case, we again identified our first level, that is to identify the domain, understand the domain completely, and do a review literature. It doesn't, we should not think just academic people focus on review literature. No, that's wrong. Even the industry people need to focus on literature, because literature gives you a lot of insights into the methods, methodologies, techniques, approaches, methods, methodology, and so on. So you need to really focus on the literature. Even if it's a simple project, your final year project, you need to first start with your literature. Don't just dive into developing something. That's not a good practice. Once you understand the literature, people who have done the work previously, it gives you a very strong base to justify your claims or justify your work or methods. So that gives you objective 1. In objective 2, we started designing and developing interactive solutions. And once we had some kind of prototypes, we started validating them. Once you validate them, then we started refining the prototype. So that's objective 4. So we just followed this kind of 4 objectives. And to start this kind of a research, which is in collaboration with the industry, so we worked with, we identified one of the methodology called design study methodology. We call it as DSM. I'll explain you how DSM can help you turn your idea into a product and deploy them in the market. It's a simple 9-stage model. We can break this up into 3 phases. So first phase is called as precondition phase. Second phase is called as condition phase or a core phase. The third phase is nothing but analysis phase or a post-condition phase. So each phase has 3 stages. So first stage is nothing but learning stage. As I mentioned, in the learning stage, you start focusing on the literature, identify the domain. In this example, the domain is the investigation, digital crime, digital forensics, and e-discovery. So we need to understand. So when I started this project along with my team, we were very new, completely new to the digital forensics. So digital forensics is not very easy kind of a concept that you can quickly adapt and build a solution for your customers, or even to work on any research activity is not that easy. It's not straightforward. We need to really understand some key things, and a lot of groundwork is needed. So the first stage is nothing but learning stage. We need to focus completely on the learning stage, understand everything. Then we move on to the winnowing. Winnowing is nothing but identifying the collaborators. For example, let's say Christ College comes up with a DST proposal and they win a proposal and they want to collaborate with industries. So you need to identify which industry would really support in this kind of research. So that's nothing but winnowing. And you need to identify SRF or JRF or any other people for that matter. So that's nothing called winnowing. You need to identify the right people to work on this project. Casting, then you start defining the roles and responsibilities for each individual. Principal investigators takes a particular role, then the co-PIs, they take a different role, then your JRFs, SRF, industry collaborators, each one you need to define a particular role and they have to stick to the role until the product is completed or a prototype is being completed. So that's nothing but casting. Once you are done with this, that which means technically you're done with the precondition phase and you're in a very strong position to move to the condition phase. Condition phase starts with something called discover. That's the fourth stage. In discover stage, you will start doing a much more detailed analysis, conduct a lot of interviews with the experts. For example, in this case, we started working with the lawyers. We started working with the investigators, analysts. We tried to capture a lot of information. We conducted interviews to understand the current problems, challenges, and how we can overcome the problems and challenges. Once you capture the functional requirements, or in simple words, just the requirements, it's easy to start designing. If you don't capture the requirements properly, you will start working on a design which doesn't make any sense to the customer or a client, or it could be even for your DST proposals. So first, we need to make sure you capture all the information completely. Make sure you have the strong base to move into the design stage. In the fifth stage, you start working on the designs. You start again with some paper designs and then you move on to building the real-time solutions. And then comes the real implementation with all the features. This completes the second phase. That's nothing but condition phase or core phase. The third phase is nothing but deploying. Once your client is satisfied and is happy, then you start deploying the solutions. It could be in the direct platform, like it could be IBM, Google, or Amazon, or it could be the client's own platform. It depends based on the projects. And once you deploy, it's always good practice to again reflect back to see if you have done everything in a right way. And the whole process is iterative. So every time you move from one stage to other stage, you make sure that you have done everything right. So you look back and you come back again. So you look back and you come back again. So this is completely an iterative model, which helps you in designing really strong solution. Your idea gets validated completely at every stage, and then you deploy the solution so that your customers or clients are satisfied. And again, after you in the final stage, you reflect completely on all the stages. Then you start publishing your papers. It could be your articles. It could be white papers. It could be presenting at various conferences. It could be filing a patent. So all the stage comes as a final stage. So my suggestion is not to do anything before that. The reason is a lot of things can keep changing. So it's not a good practice to file a patent at an initial stage. Maybe you can just get your application number. But if you want to do a complete drafting and submitting for the publication, it's a good practice to do it at the end so that you have a clarity in all the methods and the claims that you really like to claim for a patent. So this is simple, a 9-stage model. I'll walk you through each of the stages in a much clearer way so that you'll be able to understand. So as I mentioned, so DSM really works well with real world problems, real users and real data. And once you have a motivation for this project, which means technically you move into the first phase, that's condition phase, where you understand the domain, conduct a lot of interviews to understand, establish research aim, objectives and questions, do some lot of literature review, understand the state of the art techniques, identify various other challenges and issues, get the findings. So that completes the precondition phase. In the condition phase, you characterize the domain, characterize the problem, characterize the task, analytical goals. You conduct again in regular interviews to capture the requirements. Then you start translating the design requirements into goals and tasks, then develop solutions that will fit your customer needs. That's condition phase. In the post-condition phase, then you again do a lot of evaluation, validation, reflect on your work, and then it could be your thesis writing, or it could be your report, technical report, or any other submission reports for your DST or any other proposals. And it's always a good practice to come up with a timeline. Let's say that you complete your precondition phase in 3 months or 4 months. You need to put a chart. Without timeline, you should never work on any projects. Even if it's your final year students, please make sure that you have a timeline. Let's say it's a 4-month kind of a project. Every week, what are you going to achieve is very important. Without timeline, if you operate, you end up in an industry where you will be pressurized enormously, because there everything is all about time. For us, missing 1 day is almost equivalent to missing 100 days. So you need to understand, it's always a good practice to start at your college. So as a student, I would suggest you to start at your mini projects or your final year projects, come up with a timeline, then start working on each of the milestones to be achieved. To start with the phase 1, precondition phase, as I mentioned, there are 3 stages: learning, winnowing, and casting. Let's quickly see how this relates to our case study. So in stage 1, as I mentioned, we did a lot of groundwork, literature review. In our case, we started working on visualization features. We identified from the data, there are 4 main features that are part of communication data. It could be social media data or email data. In that, we identified time, that is nothing but temporal, individuals and contents, and threads. Threads are nothing but a sequence of messages being aligned. In an email, when you pick one person sends an email, then people who are CC'd or being included in the email start replying. So every time each one replies, the thread starts growing. So that's what we call it as email thread. It could be a same thing. When you post something on Facebook, people start replying, and then you start seeing a particular thread being accumulated for a particular post. So we call those as thread. So similarly, even in the email communication data, this is what 4 features that we identify: time, individuals, content. It could be what kind of information they are being sending to each other, and the thread, how the structure keeps evolving. In the second, we identified what kind of methods and techniques will be highly helpful to build solutions that can satisfy the customer. In that, we identified a lot of conventional kind of solutions, which we call it as more of traditional ones, but we were thinking how to make it a bit more unique, if that could make a lot of sense. Sometimes innovation is not about just doing for the sake of doing. It could also be something where you try to adapt from the traditional methods. So we were trying to hit the balance between conventional and the novel solutions. So that completes our literature. Of course, once you start working on literature a bit deeper, you understand what kind of solutions are being implemented by other people, whether that can fit or retrofit your solutions or existing solutions. So that's where we identified more tasks and interaction systems. That completes our stage 1. This is completely on the literature side. In the stage 2, as I mentioned, we focused on winnowing and casting. We tried to define roles for our collaborators. We defined the roles for the principal investigators. We defined the roles for other users and professionals. So this is very critical stage. This needs to be done at a very early stage. Once you miss this stage, then it's going to be really difficult, because you need to get this complete strong base in the precondition phase. So any kind of proposals you start working on, I think this is my very big suggestion. In phase 2, so we move completely from the precondition phase to the condition phase. This is the phase 2. Here again, you have 3 stages. In stage, that is, you start with the discovering stage, then you start designing, and then you start implementing them. In the discovering stage, this is where you identify a lot of challenges. You identify what will be the best that would fit your customer needs, or it could be for the society or community that you're working on projects for. Here you characterize the problem and you abstract the problems. So the 3 challenges were quite simple, but it was quite challenging as well. So identifying a lot of interesting email subsets within a large volume of communication data. So what I mean to say here is, in an organization, you have per day, people keep sending 10,000 emails actually. In one of medium scale companies, they do send 10,000 emails. I'm telling you from abroad. In India, emails are not very effective. People send a lot of things through WhatsApp messages, but in abroad, it's completely different. We focus completely on email kind of communication. Every little thing will be communicated only in email. Even a small sentence or even a small word that you want to exchange, most of the things goes only as email. In that case, there's a high probability of information being misused or information being transmitted without anyone's consent. Your organization has a compliance. So within the protocol, you need to exchange information. You cannot exchange information outside the organization. So when there's such huge data, how do you expect to quickly do some investigation? So it's not possible, right? So that's one of the challenges that we had. How do we find interesting subset of data, that is interesting kind of information being transmitted to someone. How do we identify it? So that was one challenge. Second, due to the complex and dynamic nature of email communication, the patterns vary significantly. So you cannot just do some manual investigation and identify those patterns. You need some kind of a solution to quickly identify those patterns. And then exploring the data, that is a third challenge. Exploring them, open-ended exploration is not easy. It's not easy to identify those patterns. Again, you need a simple solution or a bit sophisticated solution that can help in exploring the data. So these are the three challenges that we identified, and it's always a good practice to come up with the challenges and then address them in your designs. So in the discovering stage, in the stage 4, we try to characterize the data now. We identified a couple of data sets. You can get some open source data sets if you're doing some research, or if you're writing some proposals, you can always identify some data sets. If you don't have a data set, it's always a good practice to reach out to various industries. They can provide you data set. As far as, in the first stage itself, you define who your collaborators are. Are they happy to provide your data sets for you to work on? If not, you need to take some open source data sets. In the similar form, rather, we did not get real-time data, but we had open source data that is from our organization, which is of course real data. And we identified case studies. Using these, we try to get the design requirements from the clients and customers. So capturing the requirements are very important. In the discovering stage, requirements are to be captured. It has to be crystal clear. It's fine to come up with 30, 40 requirements, and then you simplify based on your time and based on customer needs. You can make sure you have 10 to 15 requirements at least at a high level. Using this, you can come up with analysis goals, what you're going to achieve. And for each of the analysis goals, you can map some of the tasks, what the user requires or the client requires. So this stage is also very critical if you want to start designing the solution. So stage 5 and 6, this is where the real work starts. Many people miss this plot. The reason is straight away they start designing it. I've seen students, I've been working with students for a very long time now. When I was undergraduate itself, I was started mentoring students. So what happens is straight away students start designing something or start developing something. That's a very wrong strategy. As professors, it's our duty to make sure students understand capturing requirements are really, really important. Once you understand the requirements, then start designing the solutions. So in our case, we did a very strong groundwork. We understood the literature, we understood the problems, and then we started identifying how we can design solution. So to design a solution, we started breaking them into 3 phases, 3 small phases. So we try to bisect them into time phase, individual phase, and the thread phase. So that this is how the data was, the data that we captured looked something very similar to what real email data looks like, but it was completely in the CSV format. There we identified time played a massive role. And of course, whenever you have a communication data, you have individuals. Of course, you have a thread because you have some kind of a sequence going on. One person sends an email, then another person replies, another person gets copied, another person again replies back. So, the thread keeps evolving. So we started bisecting them into 3 phases. We try to map each of the challenges, design requirements, analysis goals, tasks into each of the phase. So whatever we captured, we try to map it to each of the phase. This becomes easy to quickly design some solution and deploy that in the organization's platform, or it could be various other platforms. So this was one of the techniques that really helped for us. When we started designing, we started focusing more on the low fidelity prototypes. So what do we mean by low fidelity prototypes? It's very simple. For any kind of research, you start with a white paper and a color pens or a sketch. You start sketching them. What would be the real solution that you want to build? Even before you get into simulation, for example, if it's your electronics or electrical kind of a background, then you start doing again in a paper. You see how the connections are going to happen and what would be the drawbacks, where you think there might be a problem you encounter. So most of the things you need to complete in the paper format with a lot of sketches and color pens. That solves your time. You don't need to. You'll not be spending too much of time in building some certain solutions. You will try to identify the problems in the first level itself. So once you have the low fidelity prototypes, then you move into medium fidelity prototypes. In our case, we started testing on few open source platforms like IBM Watson and Tableau. We started building some quick solutions to identify whether the features would work the customers. Once we moved from medium fidelity to high fidelity, this is where we worked on our own libraries. You have a lot of front-end libraries we call data-driven documents, D3.js. So we started building those solutions directly because we had a strong ground where we identified all the problems at the first level itself. In the low fidelity, in the design itself, we understood what are the problems. And even in the medium fidelity, it gave us a little bit of insight. Then in the final stage, we were able to quickly build some solutions and push it into the platform. That is nothing but the deployment. There we identified a lot of interesting cases where individuals have sent a lot of sensitive information to various other organizations. So our solution was tested in various forms. We validated it at several levels. So what I want to say is, like, whether you're working on a proposal or whether your thesis or your final year projects, you try to do some kind of a groundwork, try to quickly address the problems at an initial level so that you build a very strong solution without any errors. So that's the logic behind this whole process. So in this case study, we try to build a solution first based on the time. We were able to quickly deploy the solution into the platform. So Redshift was one of the organizations that we collaborated with. So we were able to quickly build some solution and push it into their platform. Then we moved to phase 2. We were able to work on individual analysis, like which individual sent email to which individual, why did the individual send some email to another people, what was the network look like, why he was focusing only on certain individuals. A lot of analysis was involved. So we built that kind of solution and we again deployed in the platform, Redshift platform. Finally, thread analysis. We again identified the threads, why certain people were secretly copied in an email, why certain people did not reply to a particular email, what was the information all about. Those kind of analysis were done at phase 3. Again, this kind of solution again was pushed into the platform. Finally, we try to integrate all the solutions. It's quite easy. If you're working on a software platform, it's easy to quickly connect between all the 3 phases. As far as you know what exactly you're doing, then it's easy to interconnect 3 levels or 3 phases. That's what we did. And we started reflecting back from phase 1 to phase 3, all the solutions. This made a complete solution. And currently, Google is very happy to take up this kind of a product. So this is what I want to tell you. So in reality, when you focus on the methodology, it's easy to build a solution, effective solution. Once you have an effective solution, it's easy to invite big companies to acquire the projects. So yeah, that's the idea all about. And I can quickly walk you through some of the example solutions that we have. Currently, these kind of solutions are integrated with Gmail now. In Gmail, you can quickly access and understand your communication patterns. Let's say that an investigator or a personal user wants to analyze the email communication that's happening. He or she can click on a particular year. You can see the topmost corner, the bar charts. So there you can select a particular time frame, identify how your communication happens, whether you do it as an early morning or during the afternoon or during the evening. And when you click on a particular button, it opens up and tells you what kind of email you have sent. So the solution becomes very simple. Currently, the Gmail doesn't have this kind of solution, but whereas we have provided the solution now, this helps not only for a personal user, it also helps in any kind of investigation purposes. And when it comes to individual, then this also gives you a better insight why a certain individual is connecting with another set of people for what purpose. So this kind of, whether a person is using email or Hotmail or Gmail or Yahoo, it gives you those information as well. All the informations are being captured. And this also helps a lot in investigation. Why certain individuals are highly connected to another individual, whereas not with other people, and what kind of information are being transmitted regularly. Those informations can be captured. And when it comes to thread analysis, here we use artificial intelligence. We call it active learning mode. So constantly it gives you notification. If it's an organization, it gives notification to the HR managers or complaints managers to say that some kind of information is being transmitted outside the organization. So this helps in that, with artificial intelligence, it gives you that kind of insight. And it also gives whether communication is happening on a regular basis or irregular basis, whether it's a single thread, multi-thread, whether it's advertisement, spam. It gives you a lot of indications. And this is where the solution is more helpful for Gmail users. Hopefully, you will see this kind of solution very soon in the market. The post-condition phase is completely deploying. It could be Google, we call it as Google Suite. It could be Amazon or wherever you like to place your solutions. And stage 8 is reflecting and So in stage 7, as I mentioned, in deploying stage, we collected the data, we started archiving it, we started classifying the data, we did a lot of computing and clustering methods, we analyzed the data, and finally we deployed our solution, that is data visualization. This is completely the deployment phase, which the platform was built by Redshift, so we were able to deploy the solutions quickly into their platform. And as I always mention, like whether it's your PhD or any proposals that you write or anything of that sort, or you worked on a proposal and you need to give a technical report, it's always good to reflect back and address what are the things that you have done. Even for your thesis, it's really important. Whatever the objectives that you establish at the start, it's always good to revisit and make sure that whether you have addressed them back. So that's what makes your thesis or your work really strong. It makes it grounded. In stage 8, we were able to identify that iterative user-centered design. User-centered design is nothing but we worked with the collaborators, we worked with the customers, clients. Constantly, they were part of the whole research work and the development stage. So that's where we call that iterative user-centered design. This gave us a very good base to capture the requirements from the experts, the investigation experts. This helped us to achieve objective 1. In objective 2, we were able to again use the same design approach. We call that the DSM methodology, design study methodology approach, gave us a very good platform to build solutions with the expert, which helped us achieve objective 2. And in objective 3, again, we were able to get a very good space to validate our solutions. This gave us a very strong confidence moving into the deployment stage and to see the solution in live. So that's how we were able to achieve all the objectives. And of course, there's always findings. In any research that you do, findings are very important. You cannot just say that you have developed a solution and you cannot walk back. So you need to always identify the solutions that you have built and what are the findings out of whatever you have built. In that case, we identified 3 main findings. So iterative user-centered design gave us a strong understanding of the investigation domain. And in finding 2, multifaceted. What do we mean by multifaceted? When you combine time, individuals, content, and the threads, we call it multifaceted exploration because it helps you to click on the time and understand what kind of emails are being sent, or you click on the email and understand what kind of, at what instant of time some emails have gone and who are the individuals who are being involved. So you work either from top to bottom or bottom to top. So it gives you that kind of exploration facility. And multi-granular is nothing but you break the time into years, months, days, hours, weekdays and weekends. So that's nothing but multi-granular. So when we broke the time into multiple levels, it gave us a better understanding and better exploration. So that helps you in finding sensitive information being transmitted from one organization to another. In finding 3, we built visualization assisted active learning, which helps in classifying the communication. So it classifies spam, advertisements, small set of emails, long threaded emails, or any sensitive information being transmitted. It classifies based on the active learning approach. So these are the 3 main findings that we had. Of course, every research comes with learnings. There is no way that you go without learning. So every research comes with learnings. So you should not commit the same mistake that you have done previously. That is what makes you a super good researcher. In learning 1, we felt we could have captured more requirements at the start. But whereas the learning comes now since I'm able to explain this to you, maybe a few years back, I was not in that kind of a position to, work more on the domain requirements, but I'm now in a very good position to capture the requirements. So that's where my learning comes and I'm able to share my learning. And learning 2, it's very important to balance between conventional solutions and novel solutions. It's not easy because you already have some existing methods being proposed by various researchers. It could be from various journals and conferences, but whether to use those conventional solutions or whether to build your own solution, novel solution, is the balance that you need to create. You need to understand. You need to do pros and con analysis. We call it as feature benefit analysis. So you need to do those kind of analysis. Then if you want to really build a novel solution, go for it, or try to use existing solutions and build on top of it. So it's that careful analysis that we need to do. Even I was not able to do at that stage, but today I'm in a good position to do that. And learning 3, you need to evaluate with non-experts as well. Whatever solutions you build, you should not stick only with the experts. You need to work even with the non-experts so that your solution becomes completely optimized. You get complete feedback to build solutions. And every research also comes with principles that you define. You identify the principles based on the work that you do. In that case, we identified a lot of principles. I don't want to walk through all the principles, but at a high level, I would like to tell professors and students to focus on principles as well when you write a technical report or when you submit the report to any of the funding agencies. Focus on building principles, identify what things that you have done and how you can contribute back to the society. So people who touch your research work will be able to work on those principles. So that's the idea behind coming up with the principles. The final stage is the contribution stage or writing stage. This is where you write your technical reports, knowledge transfer reports. It could be presenting papers at various forums. It could be workshops, consortiums, symposiums, filing a patent. All this comes under writing. If you're writing a thesis, then it's your call, writing a complete thesis. So yeah, this is the last stage where you complete your all your work and you make sure that people in the future start working on your proposal or your work. So in this project, since it's an industry collaborated with academic project, so we were able to publish a lot of papers, a lot of patents has come out of our work. If you have time, you can go to my Google Scholar and read some of the articles. And if you need particular article, I'm happy to share as well. Just a quick insight into our company. Our company support in various verticals like incubation, startup, research and innovation. We provide internships to students. We provide various faculty development courses for professors. We provide training and learning. We call it as talent enablement. We provide some, support for women, youngsters who would like to come up with new ideas. We give them some kind of support funding. We support in patent filing as well. If you want to come up with product designs and development, manufacturing sectors, anything of that sort, we are happy to support. Currently, we have a global presence. We are closely working with people across the globe in Africa, Singapore, Australia, US, London, and of course in Bangalore and Chennai we have our branch. We are focusing on all the latest disruptive technologies like IoT, AI, ambient intelligence. Ambient intelligence, we are working closely with University of Putra, Malaysia. If anyone wants to work as an exchange faculty or student exchange programs, I'm happy to support. And we are also working on blockchain, cybersecurity, robotics, patent filing, and entrepreneurship development programs. As I mentioned, we have other offerings specific to talent management. We have FDP, faculty development programs, a joint PhD program. If you're interested in doing PhD, please let me know. I can connect you with the professors. You don't need to travel all the way to London, but you can do it in India. Now, currently this year, things have changed. For 2021, you can still be registered with University of London and complete your PhD in India itself. I can connect you with the right people. Then, of course, we have value-added programs, integrated courses along with University of London and other universities in US as well. Yeah, that's pretty much for today. I'm happy to take questions that if you have anything related to entrepreneurship, innovation, design, research, anything that you have, please ask me. So any questions?
Thank you, sir. Thank you very much, sir. It was very useful information regarding higher studies and everything, sir, and new technologies. Now we invite Dr. Tyagarajan to deliver the vote of thanks, sir.
Thank you.
Thank you. Thank you very much.
So am I audible?
Yes, sir.
Okay. So good noon to everyone. So I'm here to present the vote of thanks. I would like to thank the most eminent and most flexible Dr. Mithil for enlightening us with a skill of expertise. And today it was a great day with shower of knowledge and interesting things. So I'm pretty sure the precious knowledge that was shared by Dr. Mithil gave us as well as strengthened us to move forward to get into a good entrepreneur. And apart from that, with these short words, so I would like to highlight that this particular seminar will definitely enlighten the faculties, research scholars, and undergraduate students in their studies as well as in the future. So a special thanks to the IIC team, specifically the IPR coordinator and his members for their unflinching support and coordination. And by heartfelt thanks to our students for active participation. With these warm words and a kind message, we move to the end of today's seminar. Thank you.
Thank you, sir. Thank you so much for the lovely invite. It was fantastic talking to you other day and today for delivering the talk. I hope this can make a difference to the students and the professors who are trying to make the prototype into a product and pushing it to the market.
Yeah, sure.
So you can reach out to me, sir. I'm happy to support.
Definitely. So now they would have got some elaborate as well as some claims about what they can able to do, both the faculty as the research scholars.
Sure.
So,
My only request is motivate a lot of students to build a product for the community, not just for academic purpose and not for marks. If you can motivate this to the students, I think this will make a massive revolution.
Sure, sir. We'll just take your words. There's no issue.
Thank you, sir. Definitely, sir. Thank you so much, sir.
So
thank you, everyone.
Thank you so much for joining us today.
It's my pleasure, sir. It's my pleasure. Thank you, everyone. Jairaj, sir, and everyone. Thank you so much.
Thank you so much, sir. Thank you.
Thank you, sir. Bye. Bye, sir. Bye.
Bye, Dr. Mithul. Bye.
Everyone be online, please. Now, Himayandan sir will post the feedback link. Kindly, every student fill in the feedback link which will be sent to you. Everyone kindly fill the feedback link. Himayandan sir will post.
Yes, sir. I'm doing it.